I'll wait a second until it shows up. Or are you? Oh, there it is. Excellent. So before I go directly into the demonstration, just for brief context, of course, TRAKSYS is designed to be flexible, where you can interchange parts, you can interchange pages very easily, and we build solutions using various definable blocks of capabilities and content. So of course, I'll show you some demonstrations of how we handle production and management from various ranges to target both the batching and the OEE type solutions. And of course, also the inventory management that you mentioned for things like track and trace and serialization. But keep in mind that they're built off of these different defining blocks. And for different clients, production management and inventory management mean different things. So of course, I'll show you an example, but I'm more than happy to take questions and explain in case what I showed doesn't match with what you expect. So please ask questions as we go.
Sure,
Yeah.
sure, sure, Christopher.
And then just as a side note for the data itself, this will be a demonstration, so we're not connected to other environments. It is isolated. So much of the data is either simulation or manually input. In any scenario, though, if I do something manually and you have it existing in another system, we can automate that process through the use of our services. So the logic service for real-time data, data management service for non-real-time, but of course, for a demonstration, it's going to be a little simpler. If you have questions as we go as well relating to how data gets into the application or how that would look different, where if it was automated, likewise, please feel free to ask so we can have that discussion.
Yeah,
So that aside, this is the TRAKSYS demonstration. So there's a couple of different environments. The most comprehensive one is this Orange County vitamin example that shows more of a full MES type solution with a lot of content. We're going to be looking at it today using my login here, Christopher Gray, where I am a Parsec user, and therefore, in this demo at least, I have full administrative access. So we're going to have every option, every button that you can use. Of course, in most implementations and for most users, there may be less content or some options may not be accessible to all users. That said, let's talk a little bit about the solution. So first off, TRAKSYS, of course, wants to pull in information from all different sources. So I'm going to make the assumption that some of the data that we'll use will come from ERP systems or PLMs or warehouse or something to get started. So as a brief overview to that, of course, where that data is available, we will try to synchronize with that system so we can reduce data entry where needed. The most common example of this is going to be job information or work orders that ideally will come from an ERP. For all data imports, there's typically three main steps for this import, and at any step of this process, we can adjust to match the requirements of the other system. But the basic steps are one, get the information from the other system in whatever format it has. So if it's in a spreadsheets, if it's in a documents, if it's something we can reference from SQL, from an intermediary table or some intermediary file, we will want to pull that information in with whatever data is available. Maybe it provides us with chunks of data that represents a single record, and maybe these are the 5 fields it gives us. Whether it's 5 fields or 100 fields, we will take all the data that is there. The second part is in TRAKSYS to take that data and begin mapping it into TRAKSYS structures. So if you have a job record from ERP, we would then take that information and map it into our matching fields. So in our case, this would be a job, and these would be the standard fields for most jobs that at least relate to ERP. Things like what is it called, when is it supposed to run, how long is it supposed to run, and then what machines and what product are you trying to make. And then the third step is to merge it into TRAKSYS. So this might involve some additional processing. So in my example here, one job from the ERP system actually gets turned into 3 jobs in TRAKSYS under a parent job. The purpose for this is so that then I can have one job that links back to ERP, but I can have 3 separate execution steps for the purposes of reporting and data. So all this process, again, there's a lot of fields that can go with this, but this is the process that we're going to kind of hand wave, and I'm going to assume that's you're at least somewhat familiar with due to RFP questions and otherwise, to say, well, we want to bring in data where it exists, so you're not manually inputting this information over and over. This process is also typically not manual. So this example here is involves me clicking and filling out fields to make it very manual, but most cases it's going to be automated. And that is typically done through our data management service. So the data management service can communicate to external sources, and this can be done on a either timer basis. So every second, every hour, every day at certain times, maybe skipping certain days. Or it can be done on a triggered basis. So you can also say, do you want to sync information when you click a button, or perhaps you want to sync information anytime you finish production in TRAKSYS. You can use more conditional logic, more triggered logic, instead of just calendar logic.
In the TRAKSYS MES, the production order will be linked to the ERP, while the bill of materials will be linked to another system. Just to let you know. So it does apply. Yeah. What you're saying. Go ahead, Raul.
Yeah. No, that's right. But still, you know, so batch mix is basically best mix, you know, so that is the recipe management tool. So it will have the BOM, but again, it won't be directly interfacing with the MES, you know, probably batch mix will send the BOM to M3, and M3 will be sending that data to MES, you know. Yeah.
Oh, okay, I got it.
Okay. Yeah. Maybe Christopher, just one question over here. So the batch optimization, so that will also be done by TRAKSYS, right? I receive a production order from ERP, you know, and based on the equipments that are available, say like mixer, if there are two mixer available with different capacity. So TRAKSYS has the capability to, you know, suggest which is the best suited mixer based on, you know, the optimized batches that can be created. Like,
yes. So if you want TRAKSYS to handle that, we have a capability called algorithmic production scheduling. Essentially, we take this original data from ERP to say, when did you want the job to start? What do you want to make? And we utilize a number of configuration elements that can tell us what can be produced where and other limiting factors or other constraints. This includes a number of different configurable entities. For example, you can use product sets to group together products that can be produced. And this allows you to create different mixes on systems. And basically what that means is you could say, I have 3 systems. Product 1 can be made on lines, or well, say product A. Product A can be made on line 1 and 2, but not line 3. And product B can be made on lines 1, 2, and 3. So you can define subsets. You could define changeovers for groups and how long a changeover takes, and these are unidirectional. You could define schedules that go with each individual assets, including resources that are available. You could define material constraints and inventory. And what we do is we have this production scheduling engine that says, we'll take all of this information, all of these jobs, and we will create for you what we call stages. Stages are example schedules. These are not live schedules, at least not yet. But you can say, I want to schedule these jobs, and you can choose how do you want to prioritize. So you can say, for example, the most important thing to you is planned start date time score. What this means in non-TRAKSYS terms is I want the larger this number is, the more we want to keep the original ERP scheduling as much as possible.
yeah.
You can do things like changeover duration, where the higher that this number is, the more important it is to reduce changeover. So the larger this is, the lower total changeover that you should see. And TRAKSYS can take them and optimize them. If you allow it to change it, it can swap which line jobs go on, and it will try to find the best ordering for all of it. Again, this is just going to create a stage. So the first step here is it will create a schedule and say, here is an example. This is not a live schedule yet. If you like this, you commit. If you don't like it, you either make a new one or you start making manual changes to this. But we can do some fairly complicated scheduling. especially with just the standard capabilities. And then as with everything else in TRAKSYS, we do have ways to extend this logic. So if our standard logic does not accomplish all of your requirements, we can add to the standard ones.
Yeah.
So that at least handles the basic portion of jobs and job information. But again, this pattern does apply to everything else. You mentioned having another system that will provide the bill of materials. I missed the first one, but you said it feed through M3, and it would provide that information to TRAKSYS, and it would likely use a very similar pattern, of course, with different tables and different fields, but similar patterns.
Yeah.
Likewise, sorry, is there a comment?
Yes, sorry, one question, this Luis Pedrosa, and I am totally ignorant about this. So one question, the scheduling is on a daily basis, or do you have like a monthly or weekly scheduling?
So this scheduling can happen whenever you like. As you saw, I clicked a button and it scheduled it. Most typically, this is not meant to replace ERP scheduling. It is meant to assist with real-time scheduling when you have issues with production to be able to create a new optimized schedule while doing it quickly. In most cases, if you had an issue, let's say your line 1 had a problem and it went down for maintenance and it's going to be down for 4 hours. If you wanted to go back and reschedule through ERP, it would typically take a couple of steps to get ERP the new information, schedule it, and then get it back into TRAKSYS, which would be slow. We can instead, or this is basically offering an alternative where we can use constraints, like maybe we have to keep to the original sequencing. That's a common one. And we can provide a quickly done, but still fairly optimal reschedule for at least the next couple of days before you can have a dedicated system do a significant in-depth schedule as well.
Okay. So it's really a fine tuning of whatever we get from the ERP.
Most commonly, yes. And some clients do use it more extensively. That does require more developments, but it can become more powerful. But what I described is the more common.
Okay. It's good to know that we have that too. Thank you.
Along those lines too, though, it is good to note this again can be triggered at any time, and it can also be triggered automatically. So when we talk about tracking your process in a minute, well, in a little bit, anytime there is an exception, so if your machine goes down for a downtime and it's down for 5 minutes, maybe 5 minutes isn't an issue. But maybe at the 1 hour mark, if it's still down, you could have it automatically create these stages just in case with a new schedule. So that this can also feed into an automatic process to help as a response to unexpected downtimes, which is very, very powerful.
Yeah. Christopher, just one question over here. So what is the recommended approach? What would you recommend? Like scheduling the first part, let it be taken care by ERP, and then when it comes to MES, it comes along with date and work center on which the schedule has to run. And in case there are any real-time changes, on the shop floor, then those adjustments be made in MES. What approach would you prefer? Would you prefer this approach, or let the entire scheduling be handled by MES?
It depends a bit upon your company culture and how specific the information is from ERP. So it really it's meant to match your existing process. For example, I have a client that is using this, and their ERP system provides, of course, an accurate schedule to start with, but as part of their company culture, a operator can see their schedule and they can see these 3 jobs, but they can pick the order that they execute in. So what happens in their system is they schedule it, and then on a daily basis, they go and they provide a reschedule to reprioritize based upon what the operators did. The ERP system doesn't ever reschedule. They just, whenever we make changes, we do the schedule and commit. We just send them an update if that says it's going to change the end time of the final step of the process. So in their case, with a more relaxed scenario, then they definitely do a lot more in MES. But then I also have another clients where their scenario is a lot more rigid. They have a much more set time frame where once it is scheduled, it does not change. They always execute in the exact order, and they use MES to provide a stopgap where if something happens, they can fill it in. But they rely on ERP, so they don't use us very often for their scheduling.
Okay.
All right, so outside the scheduling aspect, again, we apply that pattern to the other data. So ideally for the bill of materials, you'll have the same pattern. And the same thing exists for warehouse. So in order to consume materials for traceability, we're going to need to have at least some basic information about lots and otherwise. If you want to provide limitations for what can be consumed, so if you want to be able to track things like expirations and material locations and material pegging before consumption, then of course we will need some warehouse information. As with the other data, this can be something that we import. So maybe click a button, pull new ERP information for purchase orders, and maybe when they're here, you validate the information. Or maybe you just do a very manual process, and every time you want to consume something, you check and see, does it exist? If it does not exist in TRAKSYS, you ask the operator to scan and fill out some information. Either way, TRAKSYS is likely going to use some items, or what we call items, to track materials that we'll use later on for the traceability. And effectively, these items are just physical things. So a case of something, a tote of something, where you identify what is the container, what does it contain, and every time something changes about this item, what is the context? So effectively, what you have are things like this, where you can go to any location and track your materials. If it is a raw material, maybe your tracking just looks very simple. We received the material at some point, and then later on we'll see consumption records. Or if it's a finished good, you'll be able to track it and see maybe, again, some simple movements where it doesn't change often, but you can see it links to consumption records. So we'll eventually have some genealogy that goes with it. I will be coming back to this in a little bit. We'll first look at the batching process to see where some of the consumptions occur, and then we'll come back to see what the actual tree views and things look like when there's data.
Yeah.
So with those assumptions and that information prepared, the next part is to look at the actual processes. Now, to my understanding, you have processes that will want to track OEE and some processes that want to track material consumption and traceability. And depending upon the main data that you want to collect, these processes and these views end up looking very different. So for example, this is a view that is very OEE centered. As the process continues, it will primarily focus on creating KPIs, filling out gauges, and telling you why those gauges are low or why they are good. Alternatively, if you're focused more upon a process-oriented approach, you may use something like this screen, where instead of having KPI dials, this process, being slower, will care more about the steps of the process, how long each step takes, where you have overages in the steps, and certain parameters that need to be monitored throughout the process at all times. They are still very similar. They both do track a lot of the same information, but they are slightly specialized based upon the data that they want to collect. So I'm going to show both versions of this. I'm going to start first with this batching example. This one is meant to be more manual, but also to be very process oriented, where it's focused on the steps of the process and where there is non-value added time. And then I'll go through afterwards and show the packaging example, where this is more KPI oriented, where we assume there are small losses on every part, potentially, but there's enough processing speed where we don't care about the individuals, we care about the KPI as a whole. So this first one, let me start a job first. I'll ignore this bit for a moment, it's not too important. This is going to be starting the process of creating Agaville compound. And again, this screen is going to be one example where the intent here is to track what am I producing, Agaville. I'm doing the first batch of what's going to be potentially more than one batch. And for this batch, I have to follow a specific process. In this case, this process has a 13-step routing that says I'm currently on the 4th out of the 13 steps. Now, for this, the type of data that we collect is going to be focused again around specific steps of that process. So first, what are those steps? You can see here, these are all 13 of the steps of my process. For each step, you have things like an expected duration and an actual duration, where I can see this step, for example, took 16 minutes out of 12, And this is the result of an overage. So I spent too long on this. In fact, on the first page, you can see it does flag an overage. And you can see that load blender has that 4.5 minutes overage that I just referenced. Additionally, for each of these steps, I can also identify where there are materials that need to be consumed. Assuming that you've provided us with that BOM and we've got it successfully, we can say not just for the overall process, but for each individual step when you should be consuming materials. This step, for example, has 5 materials to consume, but you can see there are 2 on this step as well that are actually some of the same. So I consume some of the first and second materials here, and I consume the rest of it on here. This is the basis for batching or throughput type oriented processes. We want to track specifically during each of these steps their durations, the material requirements, and any context that would be relevant to that step of the process. You can actually collect this information in a number of ways as well. If I wanted to collect the material consumptions, I would go to a step where I'm expected to consume material. In this case, my next step here says I am expected to consume 2 materials, and I can choose to consume them using a number of different potential interfaces. So a couple examples. The first one here is if I select add, it will take me to this form where I can see there are 2 materials to add. I can either choose to add them individually, or I can use a multiple entry form. If you want to do them one at a time, it may look like a screen like this. Perhaps you have some weighing system you can use, or maybe you're using pre-weighed. So if you're just going to manually input all this data, you might have a simple form like this, maybe with some basic barcode integration. Or if you have more devices that can be integrated to provide this data, it might look something more like this, where you have perhaps a scale, and anytime they put something on the scale, they can click a button, whether it be in TRAKSYS or on the scale, and it can feed us that information. If it has a more direct connection as well, this could even automatically update. You'd be able to capture and read the values as necessary. Now, this is, of course, one example of the screen, but you can always utilize other variations of this. So 2 other examples that were developed for specific use case scenarios were the multi-entry form, where instead of showing just a couple inputs, it showed all of them in a more Excel-like pattern. So this takes a moment to build. 1 second, please. But you can see here, it shows not just the basic inputs, but all the information. And again, a much more tabular type view, more similar to Excel of input the information, all the lines, and you could save them all at once. Or if you have, again, far more automated type process, maybe you bypass this entirely, and maybe you use an alternative version of this where it simply highlights everything and shows me in real time what this looks like.
Yeah, so that's also possible, right? The entire automated process basically without any kind of manual intervention.
Yeah, or perhaps minimal, at least for demonstration. I'm going to have some manual at almost every step just so I can control more, but you could also fully automate. For example, this screen is more of an overview type screen. You see what's happening, but with this screen, I'm assuming that some of the information is available to the operator on an interface. For one of our clients, they wanted this type of a screen, or at least this type of data, but they didn't want to have to click to these screens to see the rest of it. Instead, they wanted a more condensed version. So we created this alternative view based upon their requirements. And their alternative view looked like this. You have the steps here. When you have material requirements, it shows here. And their instructions, which were far more extensive than in this demo, they needed a more front and center view. So I put, instructions in a much more center view, right? When they wanted to consume, their expectation was that they would have a barcode scanner and they would scan 2 things, the container that it was coming from, so the material, and the container it was going to. And as long as these were correct, they would highlight in green. Otherwise, it would highlight red and tell them very explicitly, this is not correct. But if it did work correctly, their automation would know how to commit the pour. So they would be able to take this and automatically pour materials. So their expectation was they scan one thing, it's good. They scan the other, and then the pour automatically commences. And they wanted 2 views here. These are the same value. This is from 0 up to their tolerance. And then this is a zoomed in version of the same chart, so they can see when it gets close. All they wanted was when it reads the automation's value, it shows it to them, and when it reaches within tolerance, it shows orange. I don't know why they wanted orange. I don't think that looks like a good color, but that's what they asked for. So orange means good, and they can say, we're done. That was their requirements. Now, this is, again, the exact same data on this page as on this page. So you can see very clearly
Yeah.
very different views
Mm.
for the same data based upon what is more important to you.
Yeah.
Now, this is, again, the more batching oriented approach, which is more process oriented, looking at steps where there are exceptions where you take too long on a step and you need to keep track of potential non-value added time. Alongside of this, there are other bits of data, including like tasks and journals and events, but those are not specific to this type of system. So I'll be talking about the rest of this in a little bit. But the important part here is you can see where we have a focus on how long should each step take. When is it over? You can see this just turned red because we are now over on the expected time. And the ability to put reasons as to why those overages occurred, so you can go through and get effective data and effective process improvements. The other variation of this was the discrete type systems. So these are the KPI-oriented ones where we focus more upon throughputs and use those to create high-speed metrics, as opposed to the slower process-oriented one that we just looked at. For this, it does have a very similar feel, but again, the screen is very different because there is a different focus on the primary metric that they want to receive. So for this screen, give it 1 second. This is generating some data in the background. There we are. We can see that it is still showing what are we doing and how are the machines running. But instead of showing steps of the process, since these are going to be very fast, we're showing exceptions or deviations from the process, times when the machines were not running, why they were not running, and how far along we are. So in this example, I'm about 1/3 of the way through my job. We can see that I've had some downtimes. I have primarily a long changeover at the start of my process that took up most of my downtime. And it quickly explains why my OEE is poor. My OEE is below average, and you can see that availability is the main reason. And we can quickly align that this changeover of 31 minutes, which is an availability loss, is why my availability is low. The goal of this screen is to show the operators why the assets are not performing properly or as good as they can, and to allow for quick real-time deductions and improvements of the process. Again, if you have different needs, then of course this type of screen changes. Instead of showing just the current job, you could also repeat this exact same process with a historical view of the last few jobs. Maybe you do want to see the current, but you want to see trends. What are the last 5 jobs? What are the last 5 jobs and their common stoppages? What is my OEE by each individual hour? Maybe it changes by shift. There's a large number of ways that this can be adjusted, again, to match your specific needs, in the same way that this batching line can be significantly adjusted with the same exact data, but a different view. When it comes to the OEE type data as well, we also find ourselves looking at more of a hybrid approach. Whereas the batching process I showed was more manual, you will commonly find in these type of KPI-oriented processes a lot more automation. But automation is, of course, it's not infallible. There's issues with the data sometimes. It could either be that the issue is incorrect, or the issue is just the data is not detailed enough to be useful. For scenarios like this, we will commonly take a hybrid approach, where you have automation that tells you information about what happened, but then you ask operations or operators to acknowledge or interact with that data. So for example, here it says I have 2 things I want the operator to verify. I want the operator to tell me, well, the automation said that there was a misplaced tray and that there was a label jam. I want the operator to say yes or no, was that correct? If it is correct, I could simply hit acknowledge and I would be done. But if it is not correct, the operator can go and change some of this information. Now we are under my account, so I have access to everything. Operators may not always have information or access to everything, but that is an option. But since I have access to all of the things, I can change everything from the definition, so the actual machine error. I could say it wasn't a case or issue, it was a different machine had a stop and the other machine was more important. And I can provide reasons. So if there was a misplaced tray, why was there a misplaced tray? Now, the different reasons that are provided are based upon the subsystem, so the machine, the line, and even the error code that was provided. So if I were to change the definition, you'd actually see these categories change as well. For example, if I say it wasn't a misplaced tray, let's say it was another label jam. If I go back to look at the categories, you'll see that I have a couple new categories that I can pick from. The idea here is that you can collect data and you can get a lot of data from automation. But if you ask your operators to acknowledge everything, it might be a lot of work for your operators. So you can take a hybrid approach where sometimes you have automatic data and you accept it. And sometimes for more critical information, you ask the operator to acknowledge it. So you ensure the important data is correct.
Yeah. And Christopher, for the CTQs, so like critical to quality parameters for the process. So if that value is coming from the automation system, it's easy enough to map those CTQ values against the batches, right?
Yes, so it depends on what the type of value is. There's realistically two main ways that this is done. The first one is either things like these critical parameters as part of a process where you track them the entire time. So these are like temperature, pressure, etc.
Yeah.
And these, of course, are just linked by a timestamp. So any bit of data that we have, whether it be events or steps of the process, downtimes, or the actual job or batch itself, these all have their own timestamps. So it's very easy to find the related data during that time. Or if it's going to be something that's more related to an individual item. So for example, in packaging, we're making cases of bottles. If it's going to be a parameter that's related to a case, then you may choose to use something more like a task or SPC for these purposes. So for these checks, you can use configurable forms to define what the different inputs are. And these inputs can be both general. So for example, you might have general quality checks that are done against any product. Or you can choose to make them also specific to the product, the assets, even the specific job or shift if you would like to. But you can see in this example, I'm doing it specific to product, where I have Agile 500 specific checks that need to be done as well.
Yeah.
Any of the data that is collected here as well is also obviously something that can be validated. So for example, a weight should not be allowed to be negative, but in the same line of thought, certain values, certain excessively high values should also not be allowed. In my case, capsule of Agile 500 is intended to contain 500 pills. So perhaps the bottle can hold 600, but that would be the absolute maximum. There shouldn't be a way for the bottle to even exist with over 600 capsules. So if I save, you'll see it does have validation that will tell me not just a logical minimum, but also you can configure logical maximums. Additionally, after this data is collected, you can also do post-processing. So if you wanted to, you could also have things like net weight automatically feed into fill weight or otherwise for the purposes of SPC and any other rule evaluation you would like. So perhaps I record the overall value. It creates data points and tracks trending, and I can see things like mean, range, sigma, and if there's any violation of any SPC rules. We do have built-in rules for all the standard Western Electric and Nelson rules, and if you have any variants to this that you would like, there are also templates that we can build into the application to match your variations specifically.
Yeah. And Christopher, these features come only if we have this KPI reporting specific license, right? By default, this will not be available in the base version, right?
So essentially all of TRAKSYS has some form of licensing feature that goes with the different data and reports that you would use. There's a couple of minor exceptions, but effectively the majority of it is licensed to ensure that you only pay for anything that you're actually going to use. So for example, this feature here specifically is using our sample definitions license, and that drives SPC and includes, well, the data structures to collect this, as well as the rules that are evaluated with it, and all the front end and chartings and stuff that would be typically associated with it.
Okay.
For both of these types of assets as well, so for the batching and the packaging, they do share some overlaps. So this capability of event acknowledgement is used by both systems. You also have the tasks that are used by both, and they both do also have material consumption. So for example, you can see here on the current job, it does specify for this particular job, I am expected to consume a certain amount of raw materials. In my charting here, we have it where it shows it by percentage. So it's always going to align nicely in the middle to let you know how far along you are in consumption of that material. And of course, if you are using warehousing, where we can track the individual items and where they are, you can of course track, well, are they prepared or not? So you can see here, for example, these 4 materials are all prepared and are currently already at the line, ready for use for this job and at least probably one more job. But you can see that's some of this, like this here, my cases are not ready. I need to go and get some cases from supermarkets, as well as I'm missing some AGUILA, which is also not been moved yet. But whenever you consume from these materials, it will, of course, create some relations. So if I were to consume AGUILA tablets here, just like with the batching, you would be able to identify what lots, what sublots, and potentially even what specific item in the warehouse you are using. And with that, that doesn't want to reload, that's fine. And with that, we would be able to associate that consumption with this particular process and this particular end product. Now, putting that together, you then have the ability where we can go back to warehousing and start looking at that genealogy aspect. So anytime we consume something, as mentioned, it does create that set of data. So for example, if I have this final finished packaged good of Drisplin 500, I can select to track it, and you'd be able to see the movement history of it, but also the consumption history of it. This consumption history can be viewed in a number of different ways. The 2 most common examples are going to be a quick view of genealogy as a tree view. This allows you to quickly see all the lots associated with it. It's not as fancy as the genealogy one, but it does allow you to very quickly identify every lot available and is more print friendly, effectively. Or you also have the genealogy diagram, which is the more traditional view of it in a, well, expandable version. So for example, this Drisplin 500 has 2 lots of tablets that were used. These tablets, based upon the code, were not produced in-house, so this one won't have a history, but this one will. So if I expand this tablet, you can see it has a compound associated with it. And this compound is also made in-house, so I can also see its history in here as well. Of course, all this data is also for you to use, so if there's other specified reports or other variations, just like with the batching and tabulating pages, or batching and packaging, we can of course adjust these and combine these views together into whatever is the most, well, actionable and user-friendly version of it for you.
So if you want to capture the equipment, the resource who worked, on it, that can also be captured, right?
Yep. And in fact, we can do this more specifically too using the lot information. In my implementation, I use a very simple convention to help with tracking. The convention is just, it's 4 numbers. So this P dot means the final product produced from a packaging process. You can see for batching, it's B dots, and for tableting, it's T dot. There it is. So I know that this is 4625, right? I could go to quality and I can look up these identifiers to get a full track for it. Now, since this is a demo, 4625 isn't actually going to have full data. So we're going to use this identifier instead. But you can see that if I track it, this will give me all of the steps. So 3614, 3613, 3614. For each system, you'll have access to, of course, their core data. Depending upon the type of system, if you're doing a process-oriented system, you'll get things like this, where it's more based upon the routing, the number of steps taken, where you had non-value added time. versus the KPI-oriented systems where it is more OEE focused or metric focused. But again, they do share different data, so they both have material records. You can see their materials. You can see any checks for QC that were done. And of course, if you want to drill into any of these, you can. So for example, I can go to material consumption here. If I go to material consumption, this will give me a couple options. First, it will show me the material consumption for all 3 steps. Let me close some of these tabs to help loading. If I wanted to drill into it, I can click into the batching one, for example, and it will take me to the batching reports. Or if I wanted to go directly into warehousing, I could begin the tracking. So for example, this is an alternative. Maybe I want to track this and see why. I can hit trace, and you can see all of the specifics, ranging from when it first entered the warehouse to when it was consumed, by what user, at what time, on what asset. So you get a lot of data here. Just a matter of how you want them connected. If you want less clicks in between these things, we can do so. Again, we just need the formats that makes the most sense for your process. Now, this is, again, one example of the overall look and feel of what an implementation can be. There are a lot of examples in this demonstration and a lot of pages, a lot of content, and a lot of discussions we can have. I don't want to go too deep into one area unless that's of interest or of use. So I want to
that
pause
is fine.
for a moment.
Yeah, no, that is fine.
One question, can we go to the utilities part? I would like to know what we can.
Utilities is honestly one of the simplest of the solutions because it's primarily just tracking consumption of a resource. But in this case, it typically refers to one of the standard wages resources, so water, air, gas, electricity, and steam. And it has the benefits of, well, being able to relate this back to production. So for example, if I take a look at my batching area, I can see how much I use over the course of time, where it went above averages or significantly above expectations. And assuming there's some basic information that could be provided to us, it is also possible to take these values and correspond them to actual dollar amounts, which is fairly popular. With this, though, again, the main benefit of tracking utilities through something like an MES system is the context. MES is typically very oriented around process-oriented data, so linking it back to the actual processing. So when I'm looking at batching, I have timestamps, but I can link it back to what was happening at that time. You can also use that to track things by production. So for example, I could look at a job, I can do an overview and say, during my job, how much energy was used. And in this case, my chart goes through and says, every time there is a downtime on my machines, we recalculate the average between those. So you can see things like I had a maintenance check over here. During maintenance, I had fairly high energy consumption. That would be a pretty good indicator that certain machines were still running despite the fact we were down for over an hour. There would be a good recommendation at that point then that during future maintenances, if you know it'll be an hour or more, perhaps you have a recommendation to shut down more of the assets to reduce energy consumption during that time.
Okay, thank you so much.
Again, I don't want to go super far into one area if it's not of interest, so I do want to see what would be most beneficial to use more of the time for. Is there more of certain solutions that you want to drill into to understand either reporting options or configuration, or perhaps other solutions that would be useful?
Yeah, maybe a bit more on batching, Christopher. So there are a few things basically, like which we really want to understand a bit in detail. So for batch management, again, as I was saying, the production order will come from ERP. Then what should be the ideal recommendation, or what would you recommend basically, that the batch orders be created in MES, or let ERP create the batch orders and send it to MES, and then MES does the actual execution. And the reason I'm,
Yeah.
the reason I'm bringing this again and again, because we also want to explore the recipe optimization part, So
Yeah.
like, if the batches are created within the purview of MES, probably, and if MES has access to the ingredients, the bill of material with the alternatives available, and if cost is also associated with those ingredients, then, it would be good enough to optimize the recipe based on cost also and availability of the alternate material, And there is one of the plant within Nutrico, where this model has been implemented, and it's really giving good amount of cost saving on the yearly basis. So that is where we just wanted to understand whether this kind of solution is really workable, and if we can have this in TRAKSYS.
Yeah. So I guess I'm going to start with the first part of your question, which was asking about doing certain components in TRAKSYS or in like an ERP system.
Yeah.
If you have an infrastructure or architecture that would allow TRAKSYS to have that information, all the information necessary from the other systems, typically making adjustments to TRAKSYS at the MES level is usually easier than adjustments at the ERP level. So if your ERP is not able to accomplish your requirements now, if you're going to be implementing the MES already, then it may be easier. And as someone who is going to be very biased towards our software, I believe it to be very much easier to make adjustments at our software level than at an ERP level.
Yeah.
So
Yeah.
if that's not the case, though, if there are limitations where the ERP system has data and TRAKSYS can't be the master for it, which is also very common, then you find yourself with somewhat of a hybrid to that approach where the ERP can provide a significant amount of that data, and then you can have something like an MES that helps to optimize it, that of course needs to provide feedback up to it. But a number of the constraints will have to come from ERP, and that might require at least some minor additions or redevelopments from the ERP side as well.
Yeah. So optimization is possible, and we can also associate price with the ingredients, right? Within MES, if you really want
Yes.
to do. Yeah. Okay.
So TRAKSYS has, we have standard data tables, we have standard data fields for a number of our entities. So for example, this is the basic field for materials that are used in a bill of materials, right? So you can identify types that can help with grouping, codes to say, how does it link back to an ERP? What does ERP call it? Units for measurements and doing conversions. But there's always a number of attributes that TRAKSYS doesn't have natively that's maybe needed for either data mapping or for context. So for a lot of our materials, a lot of our entities, products is a very common one. We have what we call attribute fields that are built in. Our entities have these fields where they can be enabled or disabled. So an example here, I only have one that is being shown, but I can take these and I can actually say, I need another field in the database. I need to say, I need a price
Yeah.
per units. And if I enable that and set it, then when I refresh, you'll see price per unit is now added. There is a little bit of development work that goes with this because you will need to do some mapping. But the important part is this development is something that is intended by the MES. So you're able to reference this with our API. It's all one line, same object, same capability. It is a standard field in the database, so you don't have to worry about custom tables or extensions to tables and maintaining them. And it is actually utilized by some of our standardized components. For products in particular, for example, we have a concept of product mapping that says when you run a product, we take some of these attributes and we push them into tags, whether those tags are OPC writeback tags for parameter values or tags that we use for data collection and data mapping. So there's standardized extensions to these to help with a lot of the flexibility. So something like price per unit isn't too common in MES, just because typically we're focused again more on the production as opposed to the cost elements. But if it's something that will be useful, there are built-in fields where you can easily use that for mapping at the product level, at the material level, at the job level, at the asset level, or otherwise.
Yeah. Yeah, and this recipe optimization is out of the box feature, right? Like we don't need any kind of additional like custom development to be done.
It depends on exactly what you're doing. So the example that I showed, this is all the standard out of the box component. So these properties, for example, these settings are standard. They have set logic. You can't change them even if you wanted to. This is the logic that we use. But we do have a concept called plugins where if you have additional logic you need to apply, we can do that. These plugins are basically just C# scripts, but they have very specific overrides to our standard logic, so you can choose to add things. But it is very easy. For example, one of the override methods is called custom score. If you wanted to say, I want to prioritize by using the least expensive materials, we would just have to say, during custom score calculation, look at the bill of materials and add together all of their cost. The higher value, the lower scoring it gets. So it's very easy to add custom scores. And while it is some development, it's standard C# and it's not going to be like you're not redeveloping an entire platform. We're basically just saying, here's a standard hook, here's a standard spot to write it. We just don't know what your logic is. Anyone with C# knowledge could very easily write the basic logic for it. And then any TRAKSYS developer can very easily hook it in.
Yeah.
Again, that's also just for the additional ones. The standard ones here, you don't need to change anything.
Yeah.
So, if it helps to, I want to show a little bit about how this is built, just to give an idea for these screens.
Sure, Christopher.
We're talking. We've gotten now a little bit to the conversation of implementation and how these things are built, and I'm referencing a lot of it built-in extensibility. So it's good to at least note when I'm talking about extensibility, how difficult of a layer am I talking about? So TRAKSYS has effectively 3 layers of content for basically everything in the application. The easiest and most visible of these are the pages themselves. So I'm going to use the pages as an example, and then I'll talk to a little bit how that relates towards like scripted development. But for pages, the pages do have 3 explicit layers, and that is either content page, visual page, or open. A content page is a full out-of-the-box page where the entire page is controlled through one set of properties. Typically, these pages have one property that is required, and everything else is optional. For example, this page is controlled through these properties. It has a name, it has a key. This is for like display and navigation. And then all it needs is a system. You need to tell it what system it's looking at. So for example, this page here is looking at line 1. And I do it through some fancy mapping. We're not going to worry too much about that. But basically, this is system 548. So in my database, it's on the system table, ID 548, and you can also grab it from the configuration. This is line 1 from packaging. And this is ID 548. So that's what it's looking at. That's how it knows. Everything else is, again, optional, but you can use this to control some elements of the page. So let's say, for example, you wanted to do a deployment, and you guys decided you don't use journals. You don't care about journals. You don't want journals. I could go and edit this and say, okay, let's get rid of journals. We're going to go to content, journals, no. And just because I know that's going to leave a gap in the page, so maybe I want the tasks to be larger. So we're going to take tasks and say top 12 instead of top 6, now that it has at least twice the space. I save that, so now you can see journals are gone, tasks are there. It's very easy to make minor adjustments like this. But if you can't make minor adjustments to everything, you gotta, there's only some properties. Obviously, we want to show you a limited number of properties, so it's easy to use. But we don't want to show you 7,000 properties. Like from charts alone, you can imagine how many properties there are. So for this, if I want to make more specific changes, you go to the second type of page in TRAKSYS, and that is a visual page. These visual pages are built using a toolkit. So let's say instead of this, I wanted a different version. Well, we have a different version that's based upon an old TRAKSYS version called TRAKSYS 8R2, and they had a page in there called Event Track. Event Track is a little older, but people still liked it, so we made a new version of it. This is the TRAKSYS 11 version of an old screen. where it is built using visual pages. And what that means is this page is not one set of properties. Instead, every part has a set of properties. So for example, this is called a header. This is a details part. This is a list view. No, this is a table view, tile, chart, etc. I can actually look at this and you can see every part here. This is one of the more complicated pages in the implementation, just from the sheer number of parts that are on it. But you can see if I wanted to do a very basic part like a header, text, icon picker, you view icons, click things, do whatever you need to. It's a very simple part. If I wanted a more complex part like a tile, it's just more properties. Still, it's text. We have a thing called expression and syntax. This is just some mapping. It's very simple once you learn it, but that's the most complex part of this. And the most complex parts in total are usually the charts themselves. But if you've ever made a chart in Excel, you're going to recognize 95% of these properties just from name. Now, if this doesn't work, then there are scripts. So you can add scripts to these pages if you need to. I have some things on here for like calculating a couple metrics. And I did build one of my own SQL statements on here, but that's just some SQL. If you know SQL, you could do it too, but not through script. So there's some logic I put on this page for mainly handling what color certain things are, but it's again not very complicated for most of it. Anyone with basic C# would be able to go through and understand 95% of this without even knowing how TRAKSYS works. The last 5-10% is like this values dictionary and small nuances. Now, this same exact pattern again applies to everything else. So like for production scheduling, if you need to, you have the basic settings here. This is the out of the box part to it. The rest of it, if you need more rules for this, all these rules are based off of configuration, and every configurable element in TRAKSYS is very similar. They're all just like configuring those parts. It's a couple tabs with text boxes, pickers, drop downs. And then if you don't have enough from this configuration, that's where you start using script to add the last parts of it. But hopefully, I think you mentioned previously, like you have some solution aspects and you want to get 90% of the way and then do like the specifics. That's the same concepts that we have. Is we hope that our standard stuff gets you a good 80-90%. The configuration gets you pretty close, and maybe the last 2 or 3% is actual dedicated scripting.
Yeah, that's what we would like to have. We just don't want to get into too much of customization and would like to use, out of the box features as much as possible. Like,
Yep, and we are definitely aligned there. I
Yeah.
promise you our implementers like it when it's easy.
Yeah, and then again, it's a challenge about the skills and resources as well. Like internally, we won't be having anybody who will have some kind of C# or some programming knowledge who can really do a bit of complex configuration. So if it's
Mhm.
just playing with the menus, and if it's easy enough, then probably the local business guy or the IT guy, he can manage, but if
Yeah.
it gets into a bit of coding, then probably you would need involvement from like system integrator or the vendor.
And another important note too is TRAKSYS is also extremely extensible in the fact that we very much like to make templates. So alongside of the ability to add your own scripted logic here, you can also standardize anything that is custom to you. And so what I mean by that is you just mentioned the concern with having resources that can maintain it. I really wish I could show an implementation I was working on, because when you have something that is custom, if you know that you will be changing it, obviously you don't want that logic to be living in a script where someone has to go into a script and change it. So we have built-in capabilities to do things like add custom properties, where these properties are built using configuration and maintained using configuration. So a developer can create a property that you can configure and maintain, and then they can reference it, which means that you can have your own custom logic that is controlled through new properties. So you can also use that to create things like custom configuration pages. So if you know you're going to be making a lot of tasks, you're going to make a lot of paper forms for people to fill out. If you don't want to have to worry about having to train people on how to do this and how to understand it. If you know that's going to be something that's common, you can instead ask about how we can make a special page to handle that configuration. For example, this is how you would configure a quality. Actually, let me show you this task. If I come over here and I hit quality control, this is the task form that comes up. The standard way to configure this is you would go to a system, you would find the system that goes with it. You go to the task definitions and you would create first the task definition itself with a name, a key, and a tag. After you've created the task definition, you come over here and you create and assign a group to it. That group can then have the actual inputs assigned where you create them one at a time and you identify certain properties. There's a lot that you can get lost in here if you're not a technical user. Instead, I knew that, so I would more realistically, I knew that at least some of my sales team would probably ask me to create tasks. And I didn't want to have to create it from scratch every time and have to ask a million questions. So I made this page originally to help with my sales team, as well as to help with some of my partners on learning how tasks work. Instead of having to worry about all of the extra task inputs here, this page looks at just tasks. It gets rid of all the rest of it. It shows you, here's your assets, pick the asset.
Yeah.
Here's your tasks. You can edit it. If you edit the task, it's not the full configuration, it's a limited configuration. Let me open these side by side so it'll load a little faster. There we go. So it's a limited configuration. If you don't know how the tags work, that's fine. You leave it at none. Someone else fixes it later. But these are all the properties that you care about if you're setting up a task to start with. After you've set up the properties, you can then control the inputs. And one of the most difficult part for people is understanding what this actually looks like. So for my task configuration page, it also gives you an example of what the task looks like. So you can change these very easily. For example, if we look at this QC one, let's say you're building this task and partway through you decide, hey, I want this to be a text box. I don't want it to be a checkbox. You can click it and understand which one it is. You can hit edit and you can change it. So instead of a checkbox, if I want a text box, I got to tell it what type of data do I want. I want them to put the whole word in. We'd say instead of a Boolean, instead of a discrete, it needs to be a string. I hit save, and you see this changes automatically.
Yeah.
So this becomes a far more end user friendly version of understanding how to do this without having to go through the entirety of TRAKSYS training. And we can do this not just for standard stuff, but for anything. I created a solution that has some very advanced production scheduling, and all of their controls are done through similar pages like this, but I used like 50 additional properties for everything that they were asking for. But they can control it just like this. And they never have to see the script behind it.
Yeah.
Gotta swap that back before I destroy some of my demo. So hopefully that gives some level of confidence, not just that if we do have to script.
Sure. Yes, sure, Christopher. In fact, thanks for the demo. It was really good. We got because for me, I think I had never seen TRAKSYS before. You might be aware that in scripting we already use it. So probably I've gone through a few presentations where I saw the snapshots actually, and yeah, I did attend the demo basically internally from Rob, but then we didn't go through the batching, and because the solution which is being used in scripting, I think it doesn't have the batching process, neither track and trace is implemented. So that's the reason we just wanted to see batching and track and trace explicitly in TRAKSYS. Yeah.
There's a lot of stuff you can do with it. It's very uncommon to have all of it at once. So I can, if you need to see other content that you don't have at a different facility, that's what we're here for.
Yeah. Thanks a lot, Christoph, for the demo and taking out your time.
I believe the original invite I received is supposed to be up for another 20 minutes. Do we still have time, or do people have to leave? Because I saw at least 1 or 2 people had to drop off the call.
Yeah, because Elizar, I think he had another meeting as well. Because we are also evaluating automation vendor, and parallel meetings are going on for automation vendor as well.
Of course.
Yeah. So Luis, Seleni, any additional questions from your side?
No, it's
Not
okay
from my end.
from my side.
Yeah. Thank you.
No question for me. Thank you.
Yeah, so thanks, Christopher and team. If there are any specific questions which come up, maybe we'll try to drop you an email and try to have answers or email, if that works.
That works
Sure.
for me.
Okay, Luis, anything you want to add, Luis Golcher?
No, not from my end. Thank you.
Okay, so thanks again.
Okay.
Thanks for the wonderful demo. And have a nice day ahead.
Thanks, everyone.
Thank you.
Thank
See
you.
all.
Bye.
Bye-bye.
Thank you. Bye.